Let's jump right into this. I was recently looking through this incredibly detailed recruitment drive from RGBSI, and honestly, it's basically a masterclass blueprint for leveling up your mechanical engineering career. In today's explainer, we're going to break down the exact anatomy of a high-demand mechanical design engineer role. We aren't just skimming a job description here. We're analyzing the very DNA of career growth in this field. Because whether you're just starting out or you're trying to break through a stubborn salary ceiling, discovering what top-tier employers are actually demanding right now is the absolute key to unlocking your future. So, you might be wondering, what does it actually take to double your salary as a mechanical design engineer? Well, what's really interesting about this question is that the answer doesn't come from just putting in the years. It comes from acquiring a very specific stack of competencies demanded by today's top employers. How do you go from entry-level pay to commanding top-tier compensation? We're going to answer exactly that by deconstructing the specific requirements RGBSI laid out for their Bangalore-based engineering roles. To get there, let's take a quick look at our agenda for this explainer. First, we'll map out the design engineer roadmap. Then, we'll dive into mastering core technical tools, followed by going beyond just software skills. After that, we'll map out your career growth trajectory. And finally, we'll talk about scaling your earning potential. All right, let's kick things off with part 1, the design engineer roadmap, and really lay that foundation. The first thing that really stands out here is the baseline. You need a solid 60% academic score in a core engineering field, like mechanical, production, automobile, or industrial engineering. But that 60% score, it's really just the ticket to enter the stadium. It definitely doesn't guarantee you a seat in the game. What's far more important is that RGBSI is looking for candidates sitting in that sweet spot of 2 to 8 years of experience. This tells us a ton about growth prospects right out of the gate. Companies are heavily investing in mid-level engineers who've already cut their teeth on real-world projects and are ready to take on some serious responsibility. And this brings us to the great divide in engineering careers today: academic knowledge versus practical experience. Companies are explicitly stating that they demand hands-on, practical experience in mechanical design, way more than just knowing classroom theory. You can memorize all the formulas for stress and strain, but if you haven't sat down and actually applied them to a 3-day part that's going to be manufactured on a real factory floor, you just aren't going to see that career growth. The blueprint for a promotion always starts with translating textbook theory into physical reality. Okay, moving right along to Section 2, Mastering Core Technical Tools, which is essentially your CAD foundation. When you master tools like Siemens NX or PTC Creo, you're doing so much more than just drawing parts. You're taking on complex, large-scale mechanical assemblies and solving genuine engineering problems. The specific skills they're demanding go way beyond the basics of part modeling and drafting. But the thing that really jumped out at me as a massive separator is large assembly management. Look, anyone can model a single bracket, right? But if you want to grow into a senior role, you need to prove you can manage a digital assembly consisting of literally thousands of interacting components without crashing the software or losing your mind. That is where your value to an employer just skyrockets. So what happens when a design inevitably needs to change? Well, you have to seamlessly navigate the engineering change order, or ECO, process. Let's break down the daily reality of this. Step 1 is analyzing the actual issue. Say a part is failing out in the field. Step 2 is implementing the modification through a formal ECO. And Step 3 is revising and maintaining the documentation. Now, this isn't just paperwork. This is core engineering governance. Engineers who completely master the ECO process are the ones trusted to lead major projects, simply because they understand how a single dimension change ripples through an entire manufacturing pipeline. Then there's the invisible glue that holds a design engineer's daily work together, managing BOMs and PLM systems. Because, let's be honest, creating a beautiful 3D model is pretty much useless if procurement doesn't actually know what parts to order. That's exactly why RGBSI specifically asks for experience preparing bills of materials, utilizing product lifecycle management tools, and having at least a basic understanding of SAP. If you want to accelerate your growth prospects, don't just be the CAD person, be the data person. Understand how your design data flows into the enterprise systems that actually run the business. Which perfectly tees up Section 3, going beyond just software skills and looking at the actual manufacturing context. You really have to balance your knowledge of standard mechanical hardware with actual fabrication processes.
On one hand, you need an encyclopedic knowledge of off-the-shelf hardware, nuts, bolts, washers, bearings. I mean, why design a custom pin when a standard OEM component costs literal pennies and saves hours of machining, right? But on the other hand, you need deep, practical manufacturing knowledge, sheet metal fabrication, machining processes, material selection. Your growth from a junior engineer up to a lead design engineer directly correlates with your ability to design things that can actually be manufactured cost-effectively. If you design a part that's literally impossible to machine, you aren't really doing engineering, you're just making digital art. Scaling your career also requires stellar communication and teamwork abilities. You aren't working in a silo here. You're collaborating closely with cross-functional teams, like product development, to improve existing products and brainstorm entirely new concepts. Plus, you have to effectively communicate your vision through technical documentation, things like manufacturing drawings, test procedures, and rework instructions. When you can clearly explain how to assemble or fix a complex product to the technicians right on the factory floor, that is when your value to management becomes absolutely undeniable. Okay, section 4. This is where it gets really exciting, your career growth trajectory and how you actually climb that ladder. When you map out the growth prospects in this field, you see a very clear, proven path from standard design engineer all the way to engineering manager. At 2+ years, you're in the trenches as a mechanical or product design engineer. But by the time you hit 4 years, armed with the CAD and manufacturing skills we just discussed, you can transition into a senior or lead role. Fast forward to 6+ years, you become an engineering specialist or a technical lead, making those high-level architectural decisions. And by 8 years, you're primed for an engineering manager position. The beautiful thing about this field is that the pathway is incredibly clear. You just have to systematically acquire the competencies required at every single step. Now for Section 5, scaling your earning potential. Let's talk about the financial reward. When we look at the earning potential for these roles in major tech hubs like Bangalore, you can see the salary scaling from roughly 5 to 8 lakhs per annum in those early 2 to 4 years. But notice the massive jump as you move into the 4 to 6 year bracket, reaching up to 12 lakhs. And then, as you approach that 6 to 8 years of solid experience, where you're leading projects, handling massive assemblies in Siemens NX, and managing complex ECOs, your earning potential spikes all the way up to 18 lakhs per annum. This perfectly illustrates the incredible growth prospects available if you strategically align your skills with what the market is desperate for. But of course, there's a little catch in the fine print. Hitting those upper salary ceilings isn't just handed to you just because you've existed in a job for 8 years. It relies directly on how deeply you've mastered the tools. Your final compensation depends heavily on your specific CAD expertise, how well you articulate your manufacturing knowledge during the interview, and naturally your previous salary benchmarks. You have to actively build your portfolio to prove beyond a shadow of a doubt that you belong at the very top of that pay scale. So let's bring it all together. If you check all the boxes on our ideal candidate checklist, hands-on experience with Siemens NX or Creo, mastery of BOM and PLM systems, a solid grasp of sheet metal and machining design, capability with engineering change orders, and a real understanding of manufacturing engineering, then you are exactly who companies like RGBSI are hunting for. And actually, if this sounds like you, they're holding an interview drive in Coimbatore for these exact Bangalore positions. You can apply directly by sending your details to the email you see right there. So as you look at your own career blueprints and the incredible growth prospects we've explored today, I want to leave you with this one thought. Which skill will you commit to mastering next to unlock your true earning potential? Because in the world of design engineering, your next big promotion is always just one mastered skill away. Thanks so much for joining me on this explainer, and I'll see you next time.